Hello, here's another parent video on parent functions. This is quadratic functions. Now, to start with, we will see which are the best points to plot for a parent function. And you have to take these points even for transformations and all other things. So let's go through it. The best points should be -2, -1, 0, 1 and 2. So let's take these points and see what the values are. -2. When we say x is -2, fx is x squared. So we do square of this. Square of -2 is +4. How about square of -1? 1. 0, 0. 1, 1. 2, 4. You could take any points, 3, 9, like that. But we have limitations on our graph, so these are very good points. So let's start plotting these points on a graph. Let me start with 0, okay? So 0, 0. Let's move on to the positive side. 1, 1 and 2, 4. So at 1 we get 1 and at 2 we get 1, 2, 3, 4. Now similarly on the negative side, for -1, 1, -1, 1, -2, 4. 2 and 2, 4. Correct. Now, you can join these points with a smooth curve. Correct. Now, this is parabola which opens upwards. Correct? And it has a vertex and the minimum at the origin. And you'll also notice that it's symmetrical about y-axis. Correct? This is y-axis and this is x-axis, and that's the origin. So that's how the parabola looks. Now, I'll also tell you one more technique of drawing a parabola as such. As you know, if you have to draw a parabola, first get to the vertex. For a parent function, what is the vertex? Vertex is 0, 0. Then you follow the steps. Steps which you have learned earlier are in the ratio of 1, 3, 5, 7, like this. So they go like this. What I mean by steps of 1, 3, 5, 7, let me explain you that. The vertex is 0, 0, so you are there at the vertex. Then first step, so when you move 1 unit to the right, then you go 1 step up. And next time, you go 3 steps up. 1, 2, 3. Do you see that? Next time it will be 5 steps, correct? We don't have space, but that's how it moves. This is when the leading coefficient is 1. If the leading coefficient is a, then the steps get multiplied by a, okay? We will see that when we draw or sketch quadratic functions later, but it's good to know now, okay? Now, let me summarize the characteristics of our polynomial. This is also called polynomial, okay? For the basic parent function, the quadratic function x squared. So let me write characteristics now. What do you think? Which characteristics can you make out from this graph? Think about which quadrant the graph is on. So the graph is on in the quadrant 2 and in quadrant 1. Is it okay? So that's the graph. So we say that you see quadrant 1. So it actually goes from quadrant 2 to quadrant 1. Why do we say 2 to 1? Because as you know, whenever you look at a graph, you have to see it from left to right. Okay? Now, what happens in quadrant 2? In quadrant 2, we see that the graph is decreasing. So it is decreasing in quadrant 2. Right? What is the interval of decreasing? Interval of decreasing is from -infinity to 0. How about quadrant 1? It is increasing. See, the value is increasing, right? So it increases from 0 to plus infinity. Correct? Now, another thing which you notice about is even symmetry. That's a very important characteristic of this function. Even symmetry is for a value of x we have value of y, and for value of minus x we have same value of y. Do you see? F of 1 is how much? 1. And f of minus 1 is also 1. Correct? So these two points are symmetric about the y-axis. Same distance apart. You check any point. For example, this point, right? So they are how many units apart? Both were at the height of 4. Correct? When x value was 2 or minus 2. So when from origin you move 2 units away, that is 2 units away. Do you see that? They are symmetric about y-axis. They were both at same y value, 4. So you'll find that we have even symmetry. In short, let me write, how do we know f of minus x is equal to f of x? Okay, that's even symmetry. What else do you see? Do we have a vertex? Yes. And at this vertex we have minimum. So if minimum at origin, this is also called the vertex of our parabola. And parabola is the name of the shape. Opens upwards. How about the end behavior? As x approaches infinity, y approaches plus infinity. Yeah, upwards. How about x approaches minus infinity? Y approaches plus infinity. Because it moves up. It's going from quadrant 2 to quadrant 1. Correct? So this. How about x and y intercepts? They are at, yes, origin. Yeah, these are some of the characteristics of our parent quadratic function fx equals to x square. So we are talking about fx equals to x square, correct? Now, this is very similar to absolute function. Do you remember absolute function? Gx equals to absolute x. Just to recall, absolute x looks like this, and square root function looks like this. Do you see that? They are very similar. In most of the characteristics you've seen, they are very similar. The question for you is to find differences between the two. Can you name 3 differences between the parent function x square and the parent function absolute x? Well, that's an exercise for you. Okay. Now, is there any other function which is even? These two are even functions amongst you have read. Think about it. We know odd functions, but I don't think any other function which you have, which are being covered in parent functions, are even. These are the only 2 even functions. We have 2 odd functions, correct? The linear and the reciprocal function. So try to get these terms: even function, odd function, and even symmetry, odd symmetry, increasing, decreasing, end behavior, vertex, x-intercept. These are the terms which will help you to characterize or to describe a graph. Okay, that's a good information about parabola. We will study a lot about parabola and its inverse and things like that. Look into the other videos to get into the details of parabola and how it is used in some of our applications. Okay, thanks for now.